guys! Welcome to BSECE 33 channel. So meron na naman tayong panibagong lesson which talks about the semiconductor diodes. Ito ang N-type and P-type semiconductors. Before we proceed to different diodes, clippers, clampers, BJT, FET, and other electronic devices, let us first talk about what is semiconductor and its two types. What is semiconductor? Semiconductor is a substance whose resistivity lies between the conductors and insulators, meaning hindi siya totally conductor and insulator, kaya't meron siyang characteristics na parang sa dalawa, ngunit di fully the same. Semiconductors are a special class of elements having a conductivity between that of a good conductor and that of an insulator. The term semiconductor arises from the ability of these materials to conduct some of the time, but not all the time. Ang semiconductor ay widely used components in electronics dahil sa characteristics na meron ito na different from the two. Semiconductor devices are extensively used in the field of electronics. For example, the transistor has replaced the bulky vacuum tubes from which the size and cost of the devices got decreased, and this revolution has kept on increasing its pace, leading to the new inventions like integrated electronics. So, ang ginagawa ng mga engineers ay nag-create sila ng mga different components na mas napapaonte ang gastos and at the same time, mas mapapalit yung size para mas magamit ito sa iba't ibang circuits. Semiconductors are such materials in which the forbidden energy gap is small and the conduction takes place if some external energy is applied. So there are three semiconductors used most frequently sa pag-construct ng electronic devices, at ito ay ang germanium, silicon, and gallium arsenide. In general, semiconductor materials fall into one of two classes, either single crystal and compound. Pag sinabi nating single crystal semiconductors, ito ay ang germanium and silicon na merong repetitive crystal structure, kung saan ang kanilang compound semiconductor gaya ng gallium arsenide, cadmium sulfide, gallium nitride, and gallium arsenide phosphide ay kinoconstruct ng two or more semiconductor materials of different atomic structures. Semiconductors has few properties as follows. Semiconductors have their resistivity, which is less than insulators and more than conductors. Mas mataas ang kanilang resistivity compare sa conductor and mas less kumpara sa insulator. We all know na pag less resistivity, more current ang flow. Semiconductors have negative temperature coefficient. The resistance in semiconductor increases with a decrease in temperature and vice versa. Therefore, resistance is inversely proportional to temperature. The conducting properties of a semiconductor changes when a suitable metallic impurity is added to it, which is a very important property. Bakit? One way to determine kung anong klase ng semiconductor ang isang component is by knowing kung anong metallic impurity ang dinagdag dito. Kaya natin nadidistinguish ang mga semiconductors because of its impurities. Makikita natin sa slide na ang semiconductors ay may two types. Ito ang intrinsic or pure semiconductors at extrinsic or impure semiconductors. And under sa extrinsic or impure semiconductors ay merong P-type and N-type. So, masasabi natin na ang semiconductors has these following characteristics. The forbidden energy gap is very small. Gaya nga naman sabi natin na the forbidden gap for germanium is 0.7 electronic volts, whereas for silicon is 1.1 electronic volts. A semiconductor actually is neither an insulator nor a good conductor. Sabi na rin natin kanina. And as the temperature increases, the conductivity of a semiconductor increases. Another is the conductivity of a semiconductor will be in order of 100 mho meter. Intrinsic semiconductor material, such as silicon or germanium, are always doped with impurity atoms to increase their conductivity. When we say intrinsic semiconductor, it is in its extremely pure form. These are the different properties of a pure semiconductor. Una, electrons and holes are solely created by thermal excitation. Pangalawa, ang number of free electrons ay equal sa number of holes. Pangatlo, the conduction capability nito ay maliit sa room temperature. In order to increase conduction capability ng isang intrinsic semiconductor, it is better na mag-add ng impurities. Gaya nga ng nasabi kanina, nadidistinguish ang kung anong klase ng semiconductor ang isang component because of its impurities. Thus, ang tawag sa process ng pag-add ng mga impurities ay doping. Ang isang doped intrinsic semiconductor na ngayon ay tinatawag ng extrinsic semiconductor. Doping is a process that involves adding impurity atoms to an intrinsic semiconductor. Intrinsic semiconductors are of limited use in the field of electronics. The impurities cause the material to conduct current in certain ways. Sometimes, the impurity is called a dopant. If an impurity has a deficiency of electrons, the dopant is called an acceptor impurity. A hole is a missing electron, or more precisely, a place in an atom where an electron should be, but isn't. A semiconductor with an acceptor impurity is called a p-type semiconductor because holes have, in effect, a positive charge. Mamaya matatakal natin kung ano nga ba ang p-type semiconductor. But for now, let us focus muna sa intrinsic at extrinsic semiconductor. An extrinsic semiconductor material, then, is one that has been doped with impurity atoms. Gaya nga ng nasabi natin kanina, ang process of adding impurities ay tinatawag na doping. Now, itong doped intrinsic semiconductor ay tinatawag ng extrinsic semiconductor. Merong two types of extrinsic semiconductor. Depende kung anong type of impurity ang dinagdag natin dito. Ito ang N-type extrinsic semiconductor and P-type extrinsic semiconductor. So, if we will distinguish kung ano pinagkaiba ng intrinsic sa extrinsic, pag sinabi natin intrinsic, ito ay nasa pure form. Pag sinabi natin extrinsic, nadagdagan na siya ng impurities or na-dope na siya. We know na extrinsic semiconductor ay may two types, ang N-type material and P-type material. So both N-type and P-type materials are formed by adding a predetermined number of impurity atoms to a silicon base. So dito sa slide na to, we will talk about the N-type semiconductor. When we say N-type material, it is created by introducing impurity elements that have 5 valence electrons or pentavalent, such as antimony, arsenic, and phosphorus. So itong mga member na ito ng isang subset of group of elements sa periodic table of elements ay tinatawag nating group 5 because each has 5 valence electrons or meron silang 5 electrons each sa kanilang outer shell. The pentavalent atom is called as a donor atom because it donates 1 electron to the conduction band of pure semiconductor atom. So let us take a look at the picture sa slide. So kung i-observe natin dito natin makikita yung sinasabi kong 5 valence electrons or 5 electrons sa outer shell ng phosphorus. Makikita natin ito sa atomic configuration. So when a phosphorus impurity is added to silicon, every phosphorus atom's 4 valence electrons are locked up in covalent bond with valence electrons of 4 neighboring silicon atoms. Meaning, yung 4 na valence electrons ng phosphorus ay nagkakaroon ng bonding sa 4 na neighboring silicon atoms na electrons. However, the 5th valence electrons of phosphorus atom does not find the binding electron and thus remains free to float. Kaya dahil ang silicon ay meron lamang 4 valence electrons, kaya 4 lamang ang pwede makipag-bond na electrons mula sa phosphorus at yung isa dito is free to float dun sa outer shell. So dito na masasabi na kaya nagiging donor siya dahil merong isang free electron doon sa atomic configuration ng phosphorus. When a voltage is applied across the silicon-phosphorus mixture, free electrons migrate toward the positive voltage end. When phosphorus is added to silicon to yield the above effect, we say that silicon is doped with phosphorus. The resulting mixture is called n-type silicon. The pentavalent impurities are referred to as donor impurities. The effect of such impurity elements is indicated in figure 1.7 using antimony as the impurity in a single base. Note that the 4 covalent bonds are still present. There is, however, an additional 5th electron due to the impurity atom, which is unassociated with any particular covalent bond. This remaining electron, loosely bound to its parent antimony atom, is relatively free to move within the newly formed n-type material. Since the inserted impurity atom has donated a relatively free electron to the structure, diffused impurities with 5 valence electrons are called donor atoms. It is important to realize na kahit na sobrang laki ng number ng free carriers ang pwedeng ma-establish sa isang n-type material, ito pa rin ay electrically neutral since ideally, the number of positively charged photons in the nuclei is still equal to the number of free and orbiting negatively charged electrons in the structure. The effect of this doping process on the relative conductivity can best be described through the use of the energy band diagram of figure 1.8. Note that a discrete energy level, na tinatawag nating donor level, appears in the forbidden band with an Eg significantly less than that of the intrinsic material. Those free electrons due to the added impurity sit at this energy level and have less difficulty absorbing a sufficient measure of thermal energy to move in the conduction band at room temperature. The result is that at room temperature, there are a large number of carriers in the conduction level. Itong mga carriers na ito ay tinatawag na electrons. And the conductivity of the material increases significantly. At room temperature, in an intrinsic silicon material, there is about 1 free electron for every 10 raised to 12 atoms. The p-type material is formed by doping a pure germanium or silicon crystal with impurity atoms having 3 valence electrons. Kung kanina ang n-type material ay merong 5 valence electrons, sa p-type naman ay 3 valence electrons. The element most frequently used for this purpose are boron, gallium, and lithium. Ito ay member ng isang subset group of elements sa periodic table of elements na tinatawag nating group 3 because each has 3 valence electrons. When we take a look at the picture sa slide, makikita natin yung 3 valence electrons ng boron or yung 3 electrons sa kanyang outer shell sa atomic configuration. Thus, when boron is added to silicon, every boron atom's 3 valence electrons are locked up in covalent bond with valence electrons of 3 neighboring silicon atoms. Meaning, yung 3 available valence electrons ng boron ay nagkakaroon ng bonding with the 3 valence electrons ng silicon. Pero natatandaan natin na ang silicon ay mayroong 4 valence electrons. Kaya, a vacant spot hole is created when within the covalent band between one boron atom and the neighboring silicon atom. The holes are considered to be positive charge carriers. Dahil ngayong boron ay mayroong 3 valence electrons lamang at ang silicon ay may 4 na valence electrons, 3 lamang ang pwedeng magkaroon ng bonding. Plus, yung silicon ay nagkakaroon ng isang free electron. Kaya yung boron ay nagkakaroon ng hole upang ma-accommodate yung isang free electron ng silicon. When a voltage is applied across the silicon-boron mixture, a hole moves toward the negative voltage end, while a neighboring electron fills in its place. When boron is added to silicon to yield the above effect, we say that silicon is doped with boron. The resulting mixture is now called p-type silicon. The trivalent impurities are referred to as acceptor impurities. The effect of one of these elements, boron, on the base of silicon is indicated in figure 1.9. Note that there is now an insufficient number of electrons to complete the covalent bonds of the newly formed lattice. The resulting vacancy is called a hole and is represented by a small circle or a plus sign indicating the absence of a negative charge. Makikita natin dito sa picture, merong positive na sign or ito yung tinatawag natin hole. Since the resulting vacancy will readily accept a free electron, the diffused impurities with 3 valence electrons are called acceptor atoms. The resulting p-type material is electrically neutral for the same reasons described for the n-type material. Kung ang n-type material ay tinatawag nating donor atoms, meron siyang 1 free electron. Ang p-type material naman ay tinatawag nating acceptor atoms dahil merong hole or hindi sapat yung valence electrons para sa bonding. So dito naman sa slide na ito, pag-uusapan natin kung ano nga ba ang pinagkaiba ng electron versus hole flow. So the effect of the hole on conduction is shown in figure 1.10. If a valence electron acquires sufficient kinetic energy to break its covalent bond and fills the void created by a hole, then a vacancy or hole will be created in the covalent band that releases the electron. Therefore, yung transfer of holes to the left and electrons to the right. Natandaan natin na ang pag-transfer of holes ay papunta sa kaliwa at ang pag-transfer ng electrons ay papunta sa kanan. The direction to be used in this text is that of conventional flow, which is indicated by the direction of flow. Majority and minority carriers. In the intrinsic state, the number of free electrons in germanium or silicon is due only to those few electrons in the valence band that have acquired sufficient energy from thermal or light sources to break the covalent bond or to the few impurities that could not be removed. Ibig sabihin, kaya nagkakaroon ng valence electrons or free electrons sa kanyang outer shell because of the sufficient energy from the thermal or light sources. In an n-type material, the number of holes has then changed significantly from this intrinsic level. For this reason, in an n-type material, the electron is called the majority carrier and the hole the minority carrier. So kung titignan natin yung figure 1.11a, makikita natin na yung negative sign ay tinatawag na majority carriers at or yung electron at yung mga positive, yung mga hole ay minority carrier. Makikita natin na meron din positive sign, meaning sila yung mga donor ions. For the p-type material, the number of holes far outweighs the number of electrons as shown in figure 1.11b. When the fifth electron of a donor atom leaves the parent atom, the atom remaining acquires a net positive charge. Hence, the plus sign in the donor ion representation. For similar reasons, the minus signs appears in the acceptor ion. Kung yung isang electron ay umalis sa isang parent atom, ibig sabihin, ang atom ay positive charge. Kapag ang isang atom naman ay nadagdagan ng isang electron, ito naman ay magkakaroon ng negative sign. Therefore, in a p-type material, the hole is the majority carrier and the electron is the minority carrier. Contrasting sa nauna kanina, makikita natin na kapag sinabi nating n-type material, electron yung majority, hole yung minority. Dito naman sa p-type material, ang hole ang siyang majority carrier and the electron is yung minority carrier. Lagi nating tatandaan na nagiging majority carrier kung sino yung mas marami ang numbers. Kung mas marami ang numbers ng hole, therefore, siya ang majority carrier, therefore, p-type siya. Kung mas marami naman ng electrons, electrons ang majority carrier, and at the same time, n-type material siya. The N and P-type materials represent the basic building blocks of semiconductor devices. So, ayun lamang po. Thank you for listening. And kung meron kayong mga tanong, just comment down below your questions. Thank you!